Hey guys, welcome to the second episode of Short Bits by Shorty. Just a few housekeeping things before I start. First of all, thanks for the feedback. I actually read all of them, and I'll go through all the major points in the next few seconds. First off, I'll keep the name as Short Bits by Shorty instead of Christian's Chemistry Corner, as one person suggested in the feedback of Poly V, because I kind of like Short Bits by Shorty. It's kind of growing on me. Shout out to Fox for the name. Say thanks to Fox for the name for me. Second thing, I lied. These are actually not 10 minutes, turned out to be 20 minutes last time. So I'll promise to keep them in 20 minutes or less because I don't have an attention span of 20 minutes anyways. Third thing, I'll try to keep the text and drawings more consistent. Thanks for that feedback, whoever said that. And fourth and last thing, I figured out how to make this thing as a single PDF as a handout in case you guys want to look at just the handout when you finish looking at the video. So you're welcome to whoever suggested I keep this as a PDF or save this as a PDF. You might have to zoom in to see things clearly when you see the PDF version. Okay, so to begin, there are two parts to this lecture. First part is 5-alpha reductase inhibitors or 5-ARI inhibitors, and there's a second part which are the PDE5 inhibitors, which I'll go through after. Okay, so the first thing you have to know about 5-alpha reductase inhibitors, or 5-ARIs, is the process of conversion from testosterone to DHT. So you see testosterone, shown here, is converted to DHT, shown here, by 5-alpha reductase, hence the term 5-alpha reductase inhibitors. And 5-alpha reductase works by the cofactor called NADPH. So remember that 5-alpha reductase works by a cofactor called NADPH. Now testosterone is converted to the DHT, so the double bond here is converted to no double bond here by this process of NADPH reducing by the single bonds with the hydrogen here. So the single bonds in the NADPH reduce the double bond here to produce no double bond here. And in this process, NADPH goes from the reduced form, because it has the single bonds from the hydrogens, to the oxidized form, where it loses these single bonds in the hydrogens to form the nitrogen cation. So basically, NADPH is a cofactor in the conversion from testosterone to DHT by the enzyme 5-alpha reductase. NADPH goes from the reduced form to the oxidized form by reducing the double bond in testosterone to no double bond in DHT. There are two 5-alpha reductase inhibitors that Dr. Zhang talked about in class. There's finasteride, and right here, and dutasteride, shown here. You're going to remember finasteride because it has a little fin at the top. So finasteride has a fin at the top, I circled in red. And dutasteroide's the other one that kind of looks like finasteride. So remember that finasteride is a type 2 selective 5-alpha reductase inhibitor, and dutasteride is a non-selective 5-alpha reductase inhibitor. So finasteride is selective for the 5-alpha reductase 2 enzyme, and dutasteride is not selective for either enzyme. So it can bind to either 5-alpha reductase 1 enzyme or the 5-alpha reductase 2 enzyme. And they do this irreversibly as irreversible inhibitors or as suicide inhibitors, which are the same term. Okay, so we probably don't have to know the little details of the mechanism, but basically just know, I think, that irreversible inhibitors form covalent bonds with their enzyme or the cofactors. In this case, finasteride and dutasteride form covalent bonds with NADPH and the enzyme 5-alpha reductase. If you want to look at the mechanism, the drawing mechanism, you can, but big point, just know that irreversible or suicide inhibitors form covalent bonds with their enzymes, specifically in this case, 5-alpha reductase, and even its cofactor NADPH. So remember, covalent bonds, irreversible inhibitors. So, finasteride and dutasteride are metabolized both by the CYP3A4 enzyme into two products each. So, finasteride, remember finasteride has the fin at the top. That's why I drew it over here. Finasteride is metabolized by CYP3A4 at the top of the fin. So, either look for a hydroxyl at the top of the fin or our carboxylic acid at the top of the fin. So finasteride is metabolized into two products, one with either a hydroxyl group at the top of the fin or a carboxylic acid at the top of the fin. Both of these metabolic products are less active than finasteride. In contrast, dutasteride, which is also metabolized by CYP3A4, is metabolized into one equally potent and equally selective product on the left, and one less active product on the left. So just like finasteride, metabolized at the top of the fin. So here's the top of the fin. Well, not exactly the fin, but the top of the molecule for dutasteride. Find the CF3 at the top and metabolize it at both sides of the CF3. So here's the CF3 at the top. Metabolize it at the left side of the CF3 and the right side of the CF3. So metabolizing at the left side of the CF3 gives you an equally potent or equally selective metabolite, and metabolizing or adding a hydroxyl group at the right side of the molecule, the top of the fin, gives you a less active metabolite. Sorry for the really fast forward, but the next section is PDE5 inhibitors. So first thing Dr. Zhang wants us to know is the catalytic mechanism and substrate specificity. So in English, what this means. Okay, so there are three important parts to this mechanism. There's the glutamine, there is the nucleotide base, so adenine or guanine, and the PDE5 part, and maybe 4, the histidine part. So the first part is the glutamine. So in this mechanism, know that glutamine right here forms a hydrogen bond network over here. So you see the hydrogens here and the hydrogens here with either adenine or guanine shown here. Well, this is adenine, and I was too lazy to draw guanine. But imagine that guanine can also be here. So glutamine forms a hydrogen bond network with adenine or guanine, which determines the selectivity for either guanine or adenine. So remember that glutamine gives a hydrogen bond network in this mechanism. And that gives the mechanism its specificity for adenine or guanine, and also the PDE5 inhibitors, which also work at the glutamine residue. Next part is the PDE5 enzyme. So PDE5 enzyme, forgot the P over there. So the PDE5 or enzyme works by hydrolyzing the cyclic phosphorus group here. So here's cyclic AMP, and here's a cyclic phosphorus group here. So aspartate of the PDE enzyme hydrolyzes the cyclic phosphorus group through two metals and water right here. So big point, remember that in order to hydrolyze or break down cyclic GMP or cyclic AMP, PDE5 uses aspartate, two metals, and water to break down cyclic GMP or cyclic AMP at the cyclic phosphorus end. So you need 2 metals plus aspartate plus water gives you breaking down of cyclic GMP or cyclic AMP at the phosphorus end. So there's a so far I talked about parts 1, 2, 3, and 4. 1, 2, and 3. Now part 4 is the histidine. Now the histidine is important because it gives a hydrophobic interaction to further break down the cyclic phosphorus end. So remember that histidine in the PDE enzyme gives hydrophobic interactions to break down cyclic GMP or cyclic AMP further. So, summary of the mechanism. Glutamine gives substrate specificity, important, by a hydrogen bond network with either adenine or guanine within cyclic GMP or cyclic AMP. The reaction of hydrolysis or breaking down of cyclic GMP or cyclic AMP at the phosphorus end is done by 2 metals, an aspartate residue, and water. This is further done, hydrolysis is further done by a histidine residue within the PDE enzyme by hydrophobic interactions right over here. So Dr. Zhang talked about 3 prototypes of PDE5 inhibitors. There's theophylline, IBMX, and papaverine. Notice that they all look like guanine or adenine, and notice that IBMX, the way I remember this is IB stands for isobutyl, and here's your isobutyl group right here. Papaverine, Papa has 2 eyes. You can see 2 eyes right here. You see that? You see the 2 eyes right here? So papaverine, Papa has 2 eyes right here. So theophylline, IBMX, and papaverine are all non-selective PDE inhibitors. So they can act at either, for example, PDE1, PDE5, PDE7, PDE9, just listing examples, basically saying these are non-selective for the PDE5 isoform of the enzyme. Okay, so there are, Dr. Zhang talked about 4 PDE5 selective inhibitors. So remember, these are more selective for the PDE5 isoform of the enzyme PDE. And let's see, he talked about 4. So there's sildenafil, vardenafil, tadalafil, and avanafil. So the way I remember these structures is let's see, sildenafil, sounds like sit, and these 2 nitrogens sit next to each other at the top, the ones I circled in red. So sit, 2 nitrogens sit next to each other at the top. Vardenafil, don't really know, but I have something for tadalafil and avanafil. So tadalafil, tad rhymes with pad, sounds like lily pad. Frogs on lily pads, and here's a little frog right here, ribbit, y'all. So tadalafil, tad rhymes with pad, might sounds like lily pad, frog sitting on lily pad, and here's your frog right here, ribbit. Avanafil, look for the hanging hydroxyl group right here. Avanafil, hanging hydroxide. Avanafil plays hangman, hanging hydroxide. So vardenafil, IDK all. But if you remember sildenafil, 2 nitrogens sit next to each other. Tadalafil, frog eyes, because frogs sit on pads, rhymes with tad, tadalafil. And hanging hydroxyl, hangman, avanafil plays hangman. You can definitely get vardenafil if these are the only options. So among these 3, remember that avanafil has the quickest Tmax, or the quickest onset, and sildenafil, vardenafil, and tadalafil have similar Tmaxs or onsets. Remember also that tadalafil has the longest T1.5 beta, or the elimination half-life. So the longest elimination half-life exists with tadalafil. And remember that these PDE5 inhibitors are metabolized by CYP3A4, like I said over here. So CYP3A4 metabolizes these PDE5 inhibitors, and they do it at the bottom of the molecules. So always look for the bottom for these PDE5 inhibitors when you're metabolizing. So over here, sildenafil is metabolized at the methyl group, vardenafil is metabolized at the bottom methyl group, and tadalafil is metabolized at the frog, or the lily pad, however you see it, over here. And the mechanism by which they are metabolized is dealkylation or demethylation, which are the same thing since methyl groups are alkyl groups too. So CYP3A4 metabolizes these enzymes by dealkylation or demethylation at the bottom methyl groups, which are circled in blue. So, just as a review, remember that I intend these videos not to be full-on lectures of the whole 20-ish slides in this lecture, or else I'd be here forever. But they're meant to go over the basic or the major points in each learning objective. So just to go over the major points that I went over, remember that testosterone is converted to DHT by 5-alpha reductase with a cofactor of NADPH. NADPH starts off in the reduced form and is oxidized to the oxidized form through the conversion of testosterone to DHT, forming in the middle an enol intermediate right here. I think I went over that. 5-alpha reductase inhibitors include finasteride and dutasteride. Remember, finasteride has a fin at the top over here where it's metabolized to form either the hydroxyl or the carboxylic acid group, and both these metabolites are less active. In contrast, dutasteride forms one equally potent or equally selective metabolite, which has the hydroxyl group at the left of the top of the tail or the fin, and one less active metabolite at the right side of the top of the fin, or the CF3. And this metabolism happens through the enzyme CYP3A4, and these act by irreversible or suicide inhibition. And this means that they form covalent bonds with both the enzyme, 5-alpha reductase, and NADPH. The second class of drugs that Dr. Zhang went over was PDE5 inhibitors. Remember that PDE5 inhibitors have four major parts to them, or four major parts in their catalytic mechanism. They have the glutamate, which forms a hydrogen bond network over here, and this determines the specificity. So remember that glutamine determines the specificity in identifying the adenine or the guanine in cyclic AMP or cyclic GMP. A PDE5, the PDE enzyme, catalyzes the hydrolysis of cyclic GMP or cyclic AMP by two metals, and aspartate, and water, which breaks down cyclic GMP or cyclic AMP at the cyclic phosphorus bond. Remember that histidine residue in PDE is responsible for hydrophobic interactions, which further breaks down cyclic GMP or cyclic AMP. There's two types of PDE5 inhibitors which stop the breakdown of cyclic GMP or cyclic AMP by stopping PDE. And these PDE5 inhibitors are theophylline, IBMX, and papaverine. Oh, wow, what is happening? So remember that theophylline, IBMX, and papaverine are non-selective, while sildenafil, vardenafil, tadalafil, and avanafil are PDE5 selective. Remember that IBMX, you can see the isobutyl group, the IB group, isobutyl group. Papaverine, Papa has two eyes. Papaverine, Papa has two eyes. See the two eyes right here. Let's see. Okay. Remember that sildenafil, two nitrogens sit next to each other. Tadalafil, lily pad, frogs sit on lily pads. Tadalafil, Avanafil, look for the hanging hydroxyl. These are PDE5 selective and are metabolized by CYP3A4 through dealkylation or demethylation. So these methyl groups, these alkyl groups, are taken away in this metabolism. So CYP3A4 takes away these methyl groups or these alkyl groups, and that's called dealkylation or demethylation. Remember, like the quickest Tmax or quickest onset is seen with Avanafil, and similar Tmaxs are seen for sildenafil, vardenafil, and tadalafil. And remember that tadalafil has the longest elimination half-life. So that's all the learning objectives in a nutshell. If you have any questions, let me know. And hope you enjoyed this 20-minute or less video. Good luck on Thursday. Also, looks like all the text and images are the same size. So whoever gave me the feedback, try to keep the images and text consistent in size. You're welcome. Got them all in the same size. Holla! Also, if you have any feedback, be sure to leave it at pollev.com/CHRISTIANRUI629. As you can see, I always try to incorporate feedback like I did with this video. So if you have any more feedback, be sure to leave it at that PolleV website, and I will get to it in the next video. Thanks for the feedback so far, guys.